Welcome to our lesson today. Uh, in our previous video, we had introduced this topic. We had introduced on how to find the stationary points and how to state their nature and how to sketch the curve. And we know that when a curve looks like an inverted U, then the nature of this stationary point, which is also called the turning point, is maximum. If we have a U, then the turning point or the stationary point is a minimum. And if we have uh, a curve that looks like this, then it's the point of inflection. This one is discussed in details in the previous video that I've made. So if it doesn't look familiar, you can feel free to go back there and check. So our first example is y is equal to uh, y is equal to 16 minus x to the power of 4. And remember we said that for us to find the stationary point, we need to find the derivative. So we are saying dy dx is equal to negative 4x to the power of 4 minus 3. And this should be common knowledge. We dropped the constant and then we brought this one down there, and then we subtracted the power by 1, as you can see here. Yes, this is not very familiar. You can go back to the previous video where we done this. So dy dx is equal to negative 4x to the power of 3. And of course this is a principle that you should have in mind, that at stationary points dy dx is 0, and therefore we equated our negative 4x cubed to 0, so that x is equal to 0. And therefore you can say that our stationary point is at the point where x is equal to 0, this one. And therefore we need to find y, so we put our x back to our equation of y, which is y is 16 minus x to the power of 4. So y becomes 16 minus 0 to the power of 4, which gives us 16. So you see this point is our turning point. It's our turning point, also called our stationary point, right? So that's the first part of the question we have completed, finding the turning point. The second part of the question requires us to find the nature of the stationary point. And to find the nature, we have two methods that we also discussed in our previous lesson. We have the method where we draw a table like the one we have here, alright, so that you have x and you have dy dx and you have diagrammatic representation, and I'm bringing in the y so that we use it for sketching, because the third part of the question says you sketch the curve, right? So what you just need to do is to uh, substitute our 0 here, for example, in the dy dx function, right, in the dy dx equation, and then you get the value of dy dx. And I expect the value of dy dx to be 0 here, because remember this is our turning point. This is our turning point, and at the turning point, dy dx must be equal to 0. So our only job is to get the neighborhood. Remember, the neighborhood of 0 in the number line. To the left is -1 and to the right is 1. So let us put negative 1 in dy dx so that we get dy dx. So the equation for dy dx is negative 4x to the power of 3. So it will be negative 4 times negative 1 to the power of 3. And negative 1 to the power of 3 is going to be negative 1. And therefore, we are going to have negative 4 times negative 1, which will give us 4, positive 4. And as we have discussed before, if you see a positive, it looks like that. That is how that curve should look like when the gradient is positive. If we put 1 in that same equation, we're going to have negative 4 times 1 cubed, and 1 cubed is 1. Therefore, the answer is going to be negative 4. And because it's a negative, then the curve looks like that at a point at where the gradient is negative, and of course where the gradient is 0, it's a horizontal line, right? Now we know the moment it looks like this, the nature is a maximum. So the stationary point 0, 16 is a maximum point. For sketching, we will go to the last bit of it. Now, before we go to the last part of it, there is a second method that we've also discussed in our previous lesson for finding the nature of the stationary point. Say it's called method 2. Method 2, where we said you get the second derivative. You get the second derivative of the function, alright? Then you check the sign. If the sign is negative, then it's a maximum, and if the sign is positive, then it's a minimum, right? So our first derivative, dy dx, is equal to negative 4x to the power of 3, right? So our second derivative, d squared dy over dx squared, is negative 12x to the power of 2, right? And the value uh, of x is, is 0. The value of x is 0. So we're going to have negative 12 times 0 squared, and therefore we're going to have 0. Therefore, uh, this method cannot be used to find to determine the nature of the stationary point. For this particular example, but in most cases it works. In most cases it works. And when you get a negative, then it means it's a maximum point. When you get a positive, it means it's a minimum point. Alright, so let's go to the third part. The third part is for us to find, to sketch the curve. Now, to sketch the curve, the only thing that we're missing is the value of y, right? And for this one, for the one for 0, we already know that the value for y is 16. So we just need the value of y for negative 1, right? And for negative 1, y is equal to 16 minus negative 1 to the power of 4, and therefore y is 16, and negative 1 to the power of 4 is is 1. So 16 minus 1 is 15. So we have our 15 there. And then when x is 1, so y is equal to 16 minus 1 to the power of 4, right? So that is still 16 minus 15, minus 1, and therefore the answer is still 16. So, of course, you probably have the graph there. The car is going to be a little bit accurate, more accurate than mine, right? So for y, I can use a scale of 5, 1 representing 5, I mean 10 centimeters representing 5, so we have 5, 10, right, 15. So 16 is somewhere up there, right, right, so 20 is there. And then for x, maybe I can use 1 centimeter to represent 1. So 1, 2, 3, negative 1, negative 2, negative 3. So negative 1, 15 is going to be there. Then 0, 16 is going to be there, on the y-axis. And then 1, 15 is going to be there, right? So you're going to have something like this, right? Depending on the scale that you use. Now I'm doing it in a rough manner. I'm expecting you to do it in a more accurate manner. And that is going to be our first example. Before moving to a second example, it is a little bit of something that we forgot to do. We forgot to the second, the Roman 2 of the question, the coordinates of the points where the curve touches the x-axis, where the curve touches the x-axis, and that is a very simple part. Now, our curve is y is equal to 16 minus x to the power of 4, and at the x-axis, y is 0. Just the same way at the y-axis, x is 0. So you just say that 16 minus x to the power of 4 is equal to y, so that the x-axis y is 0. So that you have negative x to the fourth is equal to negative 16. So that's negative, x to the fourth is 16, where both sides are negative. So if you get the fourth root, of 16, now very fast, let us find it using the factor method. We have 2. 2 goes there 8 times, 2 goes there 4 times, 2 goes there 2 times. Right, 1, 2, 3, 4. And because we are dealing with the fourth root, then because we are dealing with the fourth root, then the pair of 4 is just 2, that's just 1. So x is equal to 2. Right? So the point that this curve touches the x-axis is the point where x is equal to 2, and therefore it is the point 2, 0. Right? So allow us to go to the next part, to the part B of the question. And this is the part B of the question. And it's going to be a little bit complicated more than the first one. So it's saying, another question, y is equal to x to the fourth minus 2x to the second plus 3. And you're going to find this to do the same thing. You can feel free to pause the video and try doing it yourself so that you mark later. Okay, so we get the derivative, dy dx, going to be 4x to the third minus 4x. Alright, but now I expect that you're very good at this, right? You can easily differentiate. So we're going to say at stationary point, dy dx is 0, and therefore 4x cubed minus 4x is equal to 0. You can factor out 4x, so 4x into x minus 1, right, into x squared minus 1, sorry, equal to 0. So for x is 0, therefore x is 0, and x squared minus 1 is 0. Right, so x squared is equal to 1. Therefore, we get the square root of both sides, plus or minus. Therefore, x is plus 1 or minus 1. It's very important that when you square both sides, when you find the square root of both sides, you remember to say plus or minus, right? So we have two stationary points here. We have x is 0, when x is 0, when x is 1, and when x is 3. And that is what makes this one a very good example, right? So let's find the stationary points. So when x is 0, y becomes 0 to the power 4 minus 2, that is 0 to the power 2 plus 3. So that means the stationary point is going to be 0, 3, right? When x is 1, y becomes 1 to the power 4 minus 2, 1 to the power 2 plus 3. And that is 4 minus 2 plus 3. So 4 minus 2 plus 3 is equal, alright, so 1 to the power 4 minus 2, 1 to the power 2 plus 3, that is 1 minus 2 plus 3, and that gives us 2. So the second stationary point is 1, 2, right? The third stationary point is when x is 3. So y is equal to 3 to the power 4. No, not when x is 3. This was negative 1. Kindly take that correction. This was negative 1, right? That was the third value for x, right? So y will be negative 1 to the fourth minus 2, negative 1 to the second plus 3. And that one is also giving us 2. So the other stationary point is negative 1, 2. So we have 3 stationary points basically. We have 0, 3. We have 1, 2. And we have negative 1, 2. So if you have that one, you can give yourself a tick. Alright. So let us go to the next part of the question. Let us get the nature of the stationary points. Alright. And you can very fast get the nature of the stationary points by simply just sketching them. Let us sketch them. Alright. So this one is going to be for x is 0, this one is going to be for x is 1, this one is going to be for x is negative 1, right? So xy, xy, xy. And I'm going to deliberately put the stationary points in at the center of the table. So x is 0, x is 1, then when x is negative 1, right? And then when x is 0, of course y is 3. When x is 1, of course y is 2. And when x is negative 1, y is 2. So we're just going to consider the neighborhood. On the left hand side of 0 we have negative 1 and 1, on the right hand side. Then here we have 0 and 2. And then here we have negative 2 and 0. Alright. So I'm going to write this in a calculator. Alright, the equation is the same. The equation is y is equal to x to the fourth minus 2 x to the second uh, x to the second and then plus 3, right? So I'm just going to put negative 1 there in a calculator so that we have negative 1 to the fourth and then minus 2 negative 1 to the second and then plus 3. So the answer is going to be 2, right? The answer is going to be 2. Oh, there's negative 1 here. You don't even need to put it in a calculator. And then there is a 1 here. So this answer is definitely 2, right? So what we need to put in a calculator is negative 2. To put in negative 2 there, you find that the value is 11. If you put 0, you can get it from here. The value is 3. So here the value is 3. So we need to find 2. And currently the value is also 11. So if you sketch this curve, right, we have negative 1, 2. So let's say negative 1 is there. I'm going to make this bigger, right? I'm going to make this bigger. That's nice. So let's say negative 1 is there, negative 1, 2 is there, and then 0, 3, 3 is there. That is a turning point, and then 1, 2. 1, 2 is there. So you realize that that one is a maximum, right? And then 0, 3. 0, 3 is there. 1, 2, you've already plotted, it's there. 2, 11. This is 2. And then 4, 5, 6, 7, up to 11. So 11 is somewhere there. Alright. Alright. So 2 is somewhere there, and 11 is somewhere up there. Right. So this curve is coming like this, turning there, going like that. Right. So this one is a minimum. As you can see, it is turned like that. Looks like a U. Right. And then let us proceed. We have negative 2, 11. There is negative 2. We have a negative 2 here. And 11 is somewhere there. Right. Then we have a negative 1, 2. Negative 1, 2 is there. And then a 0, 3. So it's coming like this. Right. So this one is also a minimum. Right. So we can easily say that the stationary point -1, right, which is -1, 2. This stationary point is a minimum, and then this one is also a minimum, right? And this one is a maximum. So 0, 3 is a maximum, and then this one, that is 1, 2, 1, 2